Okay, so let's have a look at what's in version 410.67. So I've just got to the arrangement here. I'm going to select an arrangement 8. So I'll say next, and I'll just say next here. Now the first thing you will notice in this version is the removal of the buttons and replaced with these links. This has enabled me to get a lot more links on here, and I believe it looks a lot better. So one of the first things that we have, let me step down the shaft there and do a calculation, is the stress. One of the first, looking at the stress, sorry, is shaft material. So we've got a quick link to the shaft material. So I'm going to change this one to 4140. Say apply, and we've got rid of that stress, high stress message. The other thing that we've got a link here that will take me back to the arrangement. So I could click that and it will go straight back to the arrangement. I don't need to change anything right now. The other thing we've got is a new set of cartridge housings, which are sometimes called monoblock bearings. So let's just have a look what we've got with this current plumber block selection. So we've got two. If we make those both the same, we've got a critical speed of 138. We've got good minimum load ratios. We've got an NSK bearing here because SKF don't like a high axial load compared to a radial load here. So let's see if we can change that to a different bearing. Now one of the things that has changed also in this release is that the oil lubricated bearings are no longer shown under the grease option. So previously you would see some oil options in this grease list. Now they will only appear in the oil list. Okay, so let's go grease, and we'll have a look at the, we've got SKF, HFB, or for certain other customers this may have a different name. But let's have a look at that. So by default, because it's coupled, we've got a deep groove ball bearing at the drive end and a roller at the non-drive end. So let's apply that and do a calculation. And now we can see that we've got a very high lubrication RPM, which is what we need. Really good at minimum load ratios and very good lives. So let's have a look at the inlet assembly. And we've got that drawn to scale pretty much. Now these blocks have been obtained from the bearing supplier. So this particular one is by HFB. You can just do a Google search for HFB if you want to contact them. But this shaft is a custom shaft to suit our fan design. So they would need a drawing with these nominal dimensions, and they would then quote you for a complete assembly with the shaft. You would also need to give them the tolerances on the shaft where the hub fits, and possibly the coupling as well. So let's close that. The other ones that we have, which can be very useful for much higher speeds, is the oil. So let's have a look at that. We've got two sections here. We've got a 63 series and a 62 series, and that refers to the bearing type. So let's have a look at that one. Calculate. And now we've got a much lower critical speed, and that's because this bearing arrangement, if we look at the inlet assembly, we can see that we've got a large dimension here from the center line of the bearing to the end of the seal. So that's much bigger than the previous one, So Centrix has moved this back to give some clearance here, and so we've got a lower critical speed. So we can increase that obviously up to say 90, and we'll then be okay. Of course that's going to be more expensive, so where possible you can use grease lubricated